Okay, on the bench now we have a homebrew stereo amplifier, 6BQ5, with a set of potted transformers. Something I put together a while back. I don't even remember what the design's like, and I don't even remember if it works. I think it works, but may have some problems with the bias circuit when I designed it. Don't even think I have schematics anymore, but anyway, we're going to take this apart and give it a good test and see if we can get it to work. And like I said in the last couple videos, I'm thinning the herd out here, so this is another one that might go up for sale. So let's get it connected up and see if it works, and if it does, see how it performs. Okay, we have it turned on and warmed up, and I have the signal generator. I'm just set it to 400 cycles, 400 hertz. And we have the oscilloscope set up, the dummy load set up, and we have our voltmeter. And we're going to take this and see what it does. So there's our two channels, and as you can see, they're tracking pretty close. They're not perfect, but they're really close. And right about there's our clipping. Bring it down. And if we look, we're getting right around 8 volts. Well, about 8 volts. Yep. Call it 8.1. So let's do the math. 8.1 times 8.1 divided by 8. So we got about 8 watts per channel, 8.2 watts per channel, which is what I expect out of this amp. It's not ultra linear or anything like that. It's just your standard transformer. If I recall, these aren't perfect matched transformers for 6BQ5s. They actually were designed for the little 6BM8s. So it's not a perfect impedance match. We had to do a little bit of finagling to get that all to work. It's starting to come back to me a little bit. But the amp sounds good. It has tone control, bass and treble, and volume obviously, and switchable between 4 ohms and 8 ohms. So looks like a decent amp, and I'm gonna just let it run for a little while and just see how long it holds out over some time. So let's do that, and then we'll take it apart and look at some of the insides. Okay, one of the things I do remember about this is I used the design for the tone control. It was a really unique design I'd never seen before. I tried it. And believe it or not, where we're set right now with the knobs is a flat response. As you can see, actually I have to turn the bass down a little bit and the treble down almost all the way. Not quite. And with those settings right there, I'm getting a flat response from about 30 hertz up to about 20 kilohertz. So it's pretty flat. Right around 35 hertz and below, you start to get a little bit of distortion on your waveform, but that's to be expected with with tubes and things like that. But all in all, I can't really complain. Tubes are holding out. They're hot, but they're not red plating. They're all pretty consistent. I think we're in pretty good shape so far. Alright, on the bottom of the amp, looking at the inside, you can see it's pretty tight in there. But we have our power supply running down the middle. And you can see the two channels are just pretty much mirrors of one another. And the infamous bias circuit that I remember having quite a bit of problems with, getting all these resistors balanced properly, getting everything the way it needed to be. And even with that, you still, if I recall, these tubes had to be matched. So here's our tone stack, tone control, feedback circuit, everything. You can see transformer, have a noise isolation plate for the inputs, and everything's all nice and shielded going in. So there you have it. So So once again, everything seems to be working pretty well on this amp, so not really much to touch on it. I just kind of wanted to show you around the inside a little bit. It's a basic design. You have basically a 12A U7 for your drivers in the beginning, for your preamp I should say. And then your phase splitter and driver section is a 12A X7. And then your two 6B Q5s for your outputs. Alright, and we have a, looks like a noise balancing for the hum balance for the filaments. So all in all, it's a pretty good design. Nice heavy dropping resistors. You can see this one down in here that's, you know, chassis mounted. Amp should last many, many years. So not a whole lot more to talk about on this one. And again, like I said, this one's probably going to end up going out there for sale as well. And again, this is a triode connected amp. It does not have ultralinear taps or anything like that. So it's pretty basic. Switchable between 4 ohms and 8 ohms. That's what this switch is up here for the speaker matching. And that's pretty much it. Alright. Since this turned out to be such a short video, I thought I'd take this opportunity to talk a little bit about power ratings of amplifiers. How do people rate the power? You hear all the time about people saying it's this many watts or that many watts or whatever. But what does it really mean, and how do we rate this? Because there are some deceptive ways to rate an amplifier, and there's some accurate ways to do it too. So let's go over a little bit about that, because I think this will be a pretty good opportunity for that. Now the first thing you have to understand is, and I'm going to put this up on the camera mount here so that we can do a little bit of sketching here. So let me get this reconfigured. Okay, so let's talk a little bit about how power is, or output power is derived, and how we calculate it, because there's different ways that companies will classify it, and some of them aren't so honest. A lot of companies, you ever see these little amplifiers, like this for instance. It's these little T-path amplifiers, and you know, they say these are 20 watts RMS, and some of these, they're smaller than this, and they'll say 200 watts power output. So how can that be? Especially when we use Ohm's law and you look at a speaker as 8 ohms, let's say, and the power supply feeding it's 12 volts, you know that if you do the calculations, how are you possibly getting that many watts? Well, we're going to talk about that. So first of all, to understand that, we have to understand what's going on when you connect your amplifier to your speaker and you get an output. So I have my scope hooked up here, and here's my 2 channels, left and right, and I have my signal generator just set to put out a 1 kilohertz signal. Amp's already been warmed up. So if you look here, I'm putting out a signal, and it's going up into my dummy load that's off the screen. You can't see it, and I'm just reading across my 8 ohm dummy load. Okay, so you can see your signal right there, and you can see that it is reading out a voltage, okay, some type of voltage. And I have my meter set to AC, and really important that I am using a true RMS meter. That's a little more going to come into play why that's important here in a minute. We'll talk about it. So let me shut this back off for a moment. So if you look here, what we have is I've drawn a little graph here, and I've drawn a figure of a sine wave. Okay, so let's just pretend that when I look at my oscilloscope over here and I look from my 0 volt point, which is right here, there's my 0 volts, that my sine wave, or my signal coming out of my amplifier into my speakers, is rising to a peak of 10 volts and then falling and going below the 0 and going to a peak of negative 10 volts. Okay? If I measure this to this, the total voltage value, that is what we call peak to peak voltage. So peak to peak voltage would be this voltage plus this voltage. 10, the difference between positive 10 and negative 10 is a net difference of 20, so you'd have 20 volts peak to peak. Now, let's just stop right there for a minute. We know that, let me write this real quick, that watts equals V squared divided by R. Okay, so watts equals your voltage squared divided by the resistance. So if I take my 20 volts, okay, in this instance, it would equal 20 squared divided by 8 ohms. Okay, so that would be 400 divided by 8. Okay, so there we go. 400 divided by 8 would be 50. Okay, see that? So what this indicates is if we measure the peak to peak voltage, I have a 50 watt amplifier. So if I'm an unscrupulous company and I want to overrate my amplifier, I would use that peak to peak voltage and I would do my little calculation and say, you have a 50 watt amplifier. The problem is that's not entirely true. First of all, if you look at this, the voltage measured between the ground and the positive going terminal of your speaker terminals never exceeds 10 volts, because when I'm down here it's still only 10 volts, not 20, with reference to ground. Okay, so your speaker terminals are here and here, let's say, figuratively. So really you have 10 volts, not 20. Now if I do that, 10 squared divided by 8 ohms equals 100 divided by 8 equals 12.5 watts. How on earth did that happen? So, well, what is it? 12.5 watts? Or is it 50 watts? What the heck? But really, even that's not an accurate measurement of what's going into your speaker. Because really, only for this tiny little peak right up here, for this tiny little bit of time, is it actually that much energy going into the speaker. Really, a better thing would be to take an average of this waveform, because it's moving. It's AC, it's not DC. So therefore it's constantly changing, constantly moving. So really, to get a better indication of how much average power is being absorbed by the speaker or by the load, we really want to take the average. And the average, we do that by using root mean squared, which is 1 over the square root of 2, which comes out, when you split it between these two, to 0.707. Okay, so basically your RMS voltage is going to be 0.707 times your peak voltage. So if I take my V peak, not peak to peak, V peak, I'm actually putting out 0.707 times my 10 voltage, which is 7.07. Now, if we write that down, 7.07, writing this all down, times it squared, equals, all right, 49.98. Okay, so it's approximately 50. Okay, let's just say 50. Approximately equals 50 over 8. And if we take our 50 divided by 8, here we go. So 7.07 squared, which is 49.98 roughly, which is, let's just say 50. 50 divided by 8 ohms equals 6.25 watts. And that is actually the power that you should be seeing this amplifier rated at. So you can see these little T-path amplifiers that only have 12 volt supplies in them, you're going to have voltage drops or so forth in them, okay, and things like that. But after the voltage drops, you're going to have about 10 volts to work with. And if you do the math and use the RMS, basically that's really all those T-path amps put out. It's about 6 watts of good power. Now, they'll cheat. They'll talk about power out at 10% distortion. So the sound will be terrible, but it'll exceed this a little bit, and you might eke out 8 or 10 watts. But realistically, any amp that can only deliver this to the speakers is really only realistically putting this into an 8 ohm load. That's it. And that's how you rate it. Now, remember we were talking here a minute about the meter being true RMS. The reason that's so important is because your meter, as you change the frequency of that AC signal going into an AC voltmeter, the response of the meter can also change as well, and therefore it throws off its accuracy. A true RMS meter means that within a certain range of frequencies, it will compensate, and it will always give you the true RMS value of that AC signal, no matter what frequency that AC is within that range. What that means is a non-true RMS meter at line frequency, 60 cycles per second or 60 hertz, will be very accurate. But if I put 1 kilohertz or 100 kilohertz or 20 kilohertz, that reading is not going to be accurate anymore. Okay, that's why when you do this measurement that we're going to do, you want to use a true RMS meter so that you get an accurate representation at that frequency. Okay, so once again, we have a 1 kilohertz sine wave going into the amplifier, and I'm going to turn the signal back on, and we're going to increase, and I'm going to have to drop this a little bit. And I'm going to increase the volume until the amplifier clips. And we're going to watch the voltage on the voltmeter. So if you look, increasing, 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 there we go. It's just now starting to clip. And as you can see, I'm still there. So right about there, right about 8.4 volts. Okay? So let's write that down, 8.4 volts RMS. But if you look, my meter is set to 10 volts per division. Or, I'm sorry, 1 volt per division. I have the meter set wrong. I have the scale set wrong on this one. So I'm set to 1 volt per division. So if I look at 1 volt per division, I'm sorry, 10 volts per division, my fault, I'm actually getting about 10, almost 15 volts plus and minus. So I'm getting maybe a total of closer to 30 volts. All right, I'm just eyeballing it. It's not exactly that, but if you look, here's my 0 right here where the little marker is, And if I go from there to this peak, one graticule equals 10 volts plus a little more, somewhere between 12 and 15 volts. Okay, so somewhere around there. And if I go from peak to peak of that, right, that's going to be anywhere from 24 to 30 volts. Okay, so this is good to show us where it's clipping, but you really need the true RMS meter to read the actual. Now, of course, we could do our math on this, couldn't we? And we can calculate that, the actual true RMS. Or if you have a fancy scope like this, I could actually turn on the measurement and it'll measure the RMS voltage. Okay? But again, the easiest way is to use, you get a numerical value, it's very easy. Plug it in your calculator, you're good. So with that all said, let's take our calculator, and we measured 8.4 volts on the meter. So if I take 8.4 times 8.4, because my cheap calculator does not do squares, equals 70.56 divided by 8 ohm speaker, 8.82. So I have 8.82 watts. So that's actually the clean, undistorted power that this amplifier can deliver, is 8.82 watts. All right, simple as that. So once again, I hope that gives you a little understanding of how wattage works and how people can mislead you or deceive you. You get these little amplifiers on eBay, you know, for 10 bucks or 20 bucks, and they say 200 watt amplifier or something. Well, now you kind of understand how they're stretching the truth to give you that. Okay, that's not the actual rated power of the amp. So I hope that helps you out a little bit, and it also goes to show you that even with all this power in here, you're really only producing a small amount of power to your speaker relatively, but it's amazing how loud a clean amplifier like this can get at even at 8 watts. It is very, very loud when you connect this to a good efficient set of speakers, especially since it's producing that all the way across the frequency spectrum. This amp's flat. When you set these controls properly, it can be flat all the way from about 30 cycles, 35 hertz, somewhere around there, all the way up to 30 kilohertz. So this is very flat, good amp. And one of the reasons these tone controls are like this, they're set to flat right now, believe it or not, is this is a pretty unique tone control circuit. It compensates for some of the differences in tubes and so forth. Just a little different. It does color the sound, but you know, everything colors the sound really when you think about it. But if I would have put a logarithmic taper potentiometers, you know, audio taper pots instead of linear, these would probably be closer to up and down. So that's kind of why they're like that. So if I wasn't lazy, I would replace them with the proper type of pots. But anyhow, that's a little bit about how that all works, and I hope you like taking a quick look inside the amplifier. I would like to eventually sometime go a little bit more into tube amp theory. I'm probably going to be building one here in a little bit, and when I do, we'll go through step by step. But before I get to that one, I have a couple more receivers that I'm going to do videos on that I have to restore, and we'll go from there. So I hope you enjoyed the video. This is a nice short one, and I hope you have a great day. See you next time.